Welcome to Maths for E channel. A past question on vector. In the usual notation, let 3i and 2i plus 3j be the position vectors of 2 points A and B respectively with respect to a fixed origin O. Let C be the point on the straight line OB such that OCA equal pi by 2. Find OC, vector OC in terms of I and j. Let's do a little sketch with the information given. So A is 3i, a vector, the position vector of A is 3i. So OA, 3i, that's on I-axis. If and then again B is 2i plus 3j, so that's OB, another position vector of B, and the origin is O, so OA, OB, and then C is a point such that OC perpendicular to OA, CA, because of the angle OCA is pi by 2, so pi by 2. Let's do the assumption. OB is, we know this, the vector OB, which is 2i plus 3j. The C on the same line of OB, so just the vector, the parallel vector, only the modulus is different. So we just say that it's lambda distance. So lambda time OB equal OC. So the lambda is the fraction of OB. So fraction of OB is OC. So OC vector equal lambda time OB vector. Therefore, OC vector is lambda time 2i plus 3j. OA, of course, we know that 3i. So 3i plus 0j. So OA vector. In that, from that, we can work out just the vector property CA equal the position vector of C minus position vector of A. Position vector of C, which is OC, that we just found lambda time 2i plus 3j. So if I could remove the bracket, 2 lambda I plus 3 lambda j, that's OC, minus OA is only 3i, so minus 3i minus 0i. Then if you could collect I and j together, so 2 lambda minus 3i plus 3 lambda I is the CA vector. But we know OC is perpendicular to CA. So another vector property, we can use dot vector, dot product of two vectors. So OC vector and CA vector, OC dot CA, the dot product between OC and CA, vector OC dot CA. That is equal the modulus of OC, the first vector, the modulus of CA, the second vector, and the angle between the two. It's just put theta, but theta is pi by 2. Cos pi by 2 is 0. So therefore, OC vector dot CA vector is equal 0 because of the angle between those two is pi by 2. Now OC, we know that 2 lambda I plus 3 lambda j dot, and the CA vector, he found it 2j minus 3i plus 2 lambda minus 3i plus 3 lambda j, that is equal 0. If I could remove the if I could do the dot product, I dot I is 1, I dot j is 0. So I dot j will be cancelled out. So only the I and I. So 2 lambda I times 2 lambda minus 3i multiple together. That's I dot I is 1. So 2 lambda times 2 lambda minus 3 plus, and then 3 lambda I, 3 lambda j and 3 lambda j. So 3 lambda times 3 lambda, j times j is 1. So that's 1. So we can actually remove that. Lambda is not, so we can cancel out lambda. Of course, lambda is not 0. So if that cancel out, what we left with 2 lambda minus 3 plus 3 times 3 lambda equals 0. So if I could remove the brackets, 2 times 2, 4 lambda minus 2 times 3, 6 plus 3 times 3 lambda is 9 lambda, that is equal 0. From that is 4 plus 9 is 13 lambda, minus 6 take it to the other side is plus 6, therefore lambda equal 6 over 13. The question we have to answer, find the vector OC. So vector OC we know is 2 lambda I plus 3 lambda j. For 2 lambda, we just substitute the value of lambda here. So 2 times 6 over 13 is 12 over 13i, plus 3 times 6 over 13 is 18 over 13j. That's the answer for vector OC. Thank you. Please subscribe to the channel and share the contents with fellow students and friends. Thank you.